Hey everyone, just a super quick video to kind of tell you about position, velocity, and acceleration vectors. And what we got here is a Desmos thing with just a few vectors put in. Right now we have C of t defined as our curve. So this is sort of our parametric version of our curve, and then that is plotted here in gray. So you'll see a bunch of curves because we've got a bunch of sine functions defining what we're doing in the XYZ direction. We have a green vector pointing from 0, 0, 0 to that Cn. So n is going to be my parameter that's going to run around. We'll animate that in a minute, but you can see the green vector there. That's the position vector. I do have the endpoint kind of defined on the curve, that C of t curve. And sometimes you'll see people define this as R. So C, R, whichever letter you want to use, it's fine. The blue vector, right, this is basically going to be, I'm starting from Cn and then I'm going to end at C prime. So this is basically C prime or R prime, right, is my tangent vector. So this blue is going to be the tangent vector. But rather than positioning it at the origin, I'm positioning it at that point on my curve. So it's going to head down that way. And then the last one, this red one, this is, again, starting at the tail of this tangent vector. So that's kind of this Cn plus C prime, tells me I want to start there. And then I'm just going to go to the end, which is an additional C double prime. So this is going to be my acceleration C double prime. So remember, curve is position, right? This R of t or C of t would be position. First derivative velocity, second derivative acceleration. So this red vector is our acceleration vector. But again, instead of positioning the tail at the origin, I've positioned it here at the end of the tangent vector. Now, if I go ahead and animate this, you can kind of see what's going on. We have our acceleration vector basically dragging along our tangent vector, telling it which direction to go, how to change direction, all of that, which is what you think of when you think of a derivative, right? It's the rate of change. So this acceleration is telling that blue which way to change, which direction to change in, how fast to change in that direction. So it's just kind of pulling it along for the ride. And then again, that blue, the tangent vector, is telling my position vector how to change, right? So tangent, velocity, derivative of position. So it's my rate of change of position. So it's just telling my position vector how fast do you want me to change, what direction do you want me to change in, and just dragging it along for the ride. So you don't often see them positioned this way. A lot of times you'll see that maybe the tangent vector there, but definitely not the acceleration vector there at the tip of the tangent vector, or I should say the velocity vector in this case as well would be appropriate terminology. But that's really what acceleration is doing, right? It's just kind of telling that velocity which way to change, which direction to change. So you can do that for any curve, even if it's not position, velocity, acceleration. Just first derivative, second derivative tells the previous function how to change in that direction. So just thought I'd share that. Like I said, super quick video, but just to help you visualize, really what are these vectors and what are they doing as things go by, as time changes. All right. Hope you enjoyed it. We'll see you on the next one.